Okay, so imagine this for a moment. What if reality isn't exactly what it seems? What if the universe we experience every day, every star, every atom, even every thought is actually part of something much stranger? Number 10. The mathematics of reality. Look closely at the universe and something strange appears. The laws of physics are not messy approximations. They are elegant, precise equations. Particles don't behave in smooth, continuous ways. Instead, they move in quantized steps. Energy comes in packets. Light arrives in discrete units called photons. Even space and time appear to have limits. Time advances in incredibly tiny intervals known as Planck seconds, the smallest meaningful measurement of time. It almost feels as if the universe itself has a kind of frame rate. That's an unsettling idea. In computer simulations, worlds are built from tiny units, pixels and bits, combined together to create something that appears smooth. The deeper physicists examine reality, the more it resembles that kind of structure. There are also hard limits built into the universe. Nothing can travel faster than the speed of light. No matter how much energy you apply, the rule cannot be broken. It behaves less like a flexible law of nature and more like a hard-coded boundary, almost like a game world where the players simply cannot move beyond certain limits. For scientists who appreciate elegant mathematics, this structure is beautiful. For everyone else, it's a little unsettling, because if reality really runs on mathematical rules this clean, it begins to look less like chaos and more like code. Number 9. The quantum glitch. One of the most bizarre discoveries in physics is something known as the observer effect. In famous experiments like the double-slit experiment, particles behave very differently depending on whether or not they are being measured. When no one observes them, particles behave like waves, spreading out and interfering with themselves. But the moment a measurement is taken, they suddenly behave like solid particles with definite positions. It's as if the act of observation changes reality itself. Some people compare it to a trick used in video games. Game engines often avoid rendering distant details until the player actually looks in that direction. It saves processing power. Why calculate every leaf on a tree if the player isn't nearby to see it? Quantum mechanics appears to behave in a strangely similar way. The mathematics requires something called wave function collapse, where possibilities suddenly become definite outcomes when measured. No one fully understands why. Some theories suggest consciousness may play a role. Others argue it's simply a fundamental rule of physics. But either way, the behavior is strange, almost as if reality is being calculated in real time. Number 8. Cosmic pixels. When physicists zoom in far enough, the universe may stop being continuous. Some theories, like loop quantum gravity, propose that space itself is made from tiny, indivisible units. Think of them as the pixels of the cosmos. Just like a digital image appears smooth until you zoom in too far, space might only appear continuous until you reach the smallest possible scale. That scale is called the Planck length, a distance so small it's roughly 100 billion times smaller than a proton. Below that point, the equations of physics stop making sense. It's as if reality simply refuses to zoom in any further. A truly continuous universe shouldn't need a minimum resolution, but simulations do. Researchers sometimes look for hints of this structure by studying extremely energetic cosmic rays. If space really has a grid-like structure, particles might scatter differently at extreme energies. So far, the evidence isn't definitive, but the possibility remains. And if space really is pixelated, it raises a disturbing thought. Maybe reality has a maximum resolution, and maybe we've already reached it. Number 7. The code in the equations. Theoretical physicist James Gates once made a discovery that surprised many researchers. While studying the complex mathematics of supersymmetry, he noticed something unexpected buried inside the equations. structures that looked exactly like error-correcting codes. These are mathematical tools used in computer science to detect and fix mistakes in digital data. They help stabilize systems so information can travel without corruption. The strange question is this: why would something like that appear inside the fundamental mathematics of the universe? If reality were purely physical, you wouldn't necessarily expect such structures. But if reality were digital, if it were being simulated, error correction would be essential. A program running something as complex as a universe would need ways to prevent instability. Some scientists dismissed the discovery as a coincidence. Others believe it may simply be an unexplored feature of mathematics. But the idea remains unsettling, because finding error-correcting code in physics feels a little like discovering programming instructions hidden inside reality itself. Number 6. The fine-tuned universe. Physicists have long noticed that the laws of nature appear to be balanced with extraordinary precision. Constants like gravity, electromagnetism, and the strength of nuclear forces fall within extremely narrow ranges that allow stars, planets, and life to exist. If gravity were slightly stronger, stars would collapse too quickly. If it were weaker, stars might never form at all. If the strong nuclear force were just a little different, atoms themselves would fall apart. Even tiny changes could erase chemistry, planets, and life entirely. Scientists call this the fine-tuning problem. Some theories explain it through the multiverse, the idea that countless universes exist with different physical constants, and we simply happen to live in one where life works. But another explanation exists. In a simulation, the constants could simply be chosen values, adjusted until the system behaves the way the designers want, just like balancing the rules of a video game. That possibility raises an uncomfortable question. If the universe was tuned this carefully, who tuned it? Number 5. Glitches in reality. People sometimes report strange experiences, moments of intense déjà vu, objects appearing where they shouldn't, or brief sensations that time has paused. Most of these can be explained by the quirks of human perception. But physics itself has its own oddities. There are phenomena that almost feel like bugs in the system. One example is quantum tunneling, where particles pass through barriers they shouldn't logically be able to cross. Another is vacuum decay, a theoretical event where the universe could suddenly collapse into a lower energy state without warning. Even the cosmic microwave background contains unexplained anomalies, regions that don't quite match our current models of the universe. None of these are proof of anything unusual, but together they create an eerie impression. If reality were a simulation, occasional glitches might be inevitable. Every complex system has them. Number 4. The limits of knowledge. The universe seems to hide parts of itself behind absolute barriers. The most famous is the speed of light. Nothing, not matter, not information, can travel faster. This creates something called the cosmic horizon, a boundary beyond which light will never reach us. No matter how long humanity exists, some regions of the universe will remain forever invisible. That's a curious feature. In computer simulations, developers often limit the playable world to conserve resources. Why generate areas no one can reach? Reality also contains other limits. Absolute zero defines the lowest possible temperature. The Planck scale defines the smallest units of space and time. The uncertainty principle limits how precisely we can measure certain properties. They're not flexible rules, they're hard boundaries, almost like the edges of a system.
Number 3. Consciousness. Consciousness is one of the greatest mysteries in science. We can observe neurons firing inside the brain. We can measure chemical signals passing between cells. But none of that explains what it actually feels like to be aware. Why do thoughts exist at all? Why do we experience an inner voice? If the universe is purely physical, explaining consciousness becomes extremely difficult. But in a simulation framework, a different possibility appears. Your brain might function like hardware, and your awareness could be the software running on it. The sense of self could be the interface between the simulation and whatever exists outside it. That idea is speculative, but it highlights just how little we understand about the nature of consciousness. Number 2. Cosmic coincidences. Some features of the universe feel almost too perfect. Take solar eclipses. The sun is about 400 times larger than the moon, but also roughly 400 times farther away from Earth. That coincidence allows the moon to perfectly cover the sun during an eclipse. Out of countless possible planetary arrangements, we live in the one system where this precise alignment occurs. Then there's the strange effectiveness of mathematics. Equations written on paper often predict discoveries decades before we observe them: black holes, gravitational waves, new particles. Why should abstract mathematics describe reality so perfectly? Unless the universe itself is fundamentally mathematical. If the cosmos runs on mathematical rules, then perhaps it really is closer to code than we imagine. Number 1. The final test. If the universe truly is a simulation, then in principle it might be detectable. Some scientists have suggested searching for computational signatures in the structure of space itself. Others propose examining cosmic rays or the cosmic microwave background for patterns that shouldn't naturally exist. But there's a darker idea attached to this possibility. What if discovering the truth is dangerous? If the universe is a simulation with a purpose, an experiment, a test, or something else, then proving its artificial nature might interfere with that purpose. And what happens to a simulation once it's compromised? It gets shut down. The universe wouldn't end in fire or darkness. It would simply stop, like a program closing. One moment, everything exists. The next moment, silence. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.